Okay, today's video is about rationalizing technique. So what that is another way of evaluating the value of a limit algebraically. But in order for us to be able to use it, we have to know two things. First of all, you have to remember properties of limits. If I have the property or the limit as x approaches the target value of c of a quotient f of x divided by g of x, that's going to be equivalent to the limit as x approaches c of f of x, my numerator, and the limit as x approaches c of g of x in my denominator. So that means we would do like a direct substitution. So let's go ahead and do a direct substitution with the problem that is already up here. So that would entail substituting a 0 in place of x, because it says as x approaches 0. So minus 1 all over 0 because x is in the denominator here. So this naturally becomes, obviously, 0 over 0. So that's an indeterminate case. So when we have an indeterminate case, it means something else is going on that we can do. And that something is, in this case, a rationalizing technique. So if you remember rationalizing numerators and denominators before, all we have to do here is rationalize that numerator, and we're going to do it by using the conjugate. So the conjugate, if you remember, let's try a different color here. If I were going to multiply this expression times the conjugate x plus 1 plus 1. So absolute value of x plus 1. This plus will stay the same. This minus is what gets changed to a plus right here. And I have to do the same thing on the numerator and the denominator. So here we go. So let's see what develops once we do this. So let's see. This is a binomial times a binomial, so naturally FOIL that out. So you're still going to have the limit as x is approaching 0. But it's going to be first times first, which is just x plus 1. And the inners and the outers, they cancel off. That's the whole reason why we use the this method, rationalizing technique. And last times last, minus 1. In the bottom, I'm not going to do anything. I'm not going to distribute this x, and you'll see why in a second. Because I'll have x times the square root of x plus 1 plus 1. Okay, so put my parenthesis there. In the numerator, I have a plus 1 and a minus 1, so that's going to go to become a 0. So I'm still technically, a lot of students don't like to keep writing the limit, but until you switch to direct substitution, you should still keep writing limit. If you're doing scratch work on a side paper, that's another thing. So in the numerator, I'd still have x, and in the denominator, I have an x. So that's why I did not distribute that in the denominator, this x on both terms. Because the way this technique works is we end up eliminating or canceling out that x. So now I'm going to try to go to direct substitution from here. So I can drop writing the limit, and in the numerator I have a 1. In the denominator I'd have the square root of 0 plus 1 plus 1. And that now evaluates to something. So we have a 1 in the numerator, and the square root of 1 is 1, and 1 plus 1, that's a 2. So the limit as this this function right here, this part in that we started with, approaches 0, can be found analytically, algebraically, to be 1/2. So that's how this technique works. So that's an easy one. So I'm going to show you a little bit different one. If you want to see other techniques that look for this to be a 0 over 0, you can watch a previous video right up here called the dividing out technique. I made a video on that. So hold on, we're going to look at a different problem now. Okay, so here's our second example. This one looks a little bit different. But it's going to use the same technique, this rationalizing technique. But remember, the first thing we need to do is we need to make sure that I, number one, can't do it with direct substitution, but if I do try it, I end up with a 0 over 0. So if I tried that, let's see, what is 3 times 3, because my target value over here is a 3, so minus 5, and then the square root of that, minus 2 all over, well, x is now 3. So we have 3 minus 3. So as it turns out, 9 minus 5, that's 4, and the square root of 4 is 2, and 2 minus 2 is 0, so I end up with a 0 up top, and 3 minus 3, that gives us a 0 in the bottom. So the indeterminate form. So that means I'm going to try the rationalizing technique. So let's go ahead and erase. For the rationalizing technique, I'm going to multiply this by a conjugate, 3x minus 5, square root of 3x minus 5, plus 2. So notice, again, a common mistake, we do not change this minus to a plus here. We change this minus into the plus here. And whatever gets done in the numerator has to be done in the denominator. So there we go. So go ahead and multiply the top and the bottom. So up here, when I FOIL, the same thing is going to happen. I'm going to end up with the limit as x gets close to 3 of 3x minus 5, because root 3x minus 5 times root 3 x minus 5 is just 3x minus 5. The outers and inners, they add off, and negative 2 times positive 2 for the last times the last is a minus 4. And that's going to all be over. And I'm going to do the same thing as last time. I'm not going to multiply this out because something will happen in the next step. So here we go. Plus 2. Notice in the numerator, some things will simplify. So the limit as x goes to 3, let's see, 3x minus 9, my numerator will simplify to. And that's all over. I'm not going to change anything down here in the denominator yet because some stuff will cancel off. And that's one thing that we like. 3x minus 5 plus 2. So notice the top will actually factor. The 3x minus 9 will factor. So in the next step, I will write down the limit as x goes to 3 of 3 times x minus 3. So we factored 3 out of the numerator. So notice I have an x minus 3 here now, and I have an x minus 3 in the denominator that I will be looking to cancel that with. So x minus 3 in the denominator, we know that's going to cancel. And I still have square root of 3x minus 5 plus 2 that was being multiplied by. So now I can go to direct substitution to try this because the top has no variables left in it. So with direct substitution, I'm looking at 3 in the numerator, and in the denominator I have 1 times, well, 3x would be 3 times 3. 3 times 3 is 9. 9 minus 5 is 4, and then we're going to be adding a 2. So we'll just keep on going over here. 9 minus 5, that's a 4. So 4, I'm sorry, yes, 9 minus 5 is 4, and the square root of 4 is 2. 2 plus 2 gives us a 4. So the limit of this piece right here as x approaches 3 is 3/4. So that's called using the rationalizing technique. So that's another example. I'll show you one more example where it gets a little bit more hairy in the end. So example number 3, same as the first two. First, try to do direct substitution. If I substitute a 2 into this expression, what happens? Can I come up with a value? So a 2 here would give me a 10. 10 minus 5 is radical 5 here, minus radical 5 here. So that's a 0 in the top. And 2 minus 2, that's a 0 in the bottom. So a lot of times you can do this, with mental arithmetic. We're going to do the same thing. We need to use rationalizing technique. I see these radicals up here. And when I see another radical here, sometimes that means at the end I'm going to have some radicals to look at to simplify. So let's go ahead. I'd have 5x minus 5 plus root 5 all over radical 5x minus 5. Get my x in there, plus square root of 5. So again, notice, common mistake. This minus does not change, right? What changes to make the complex conjugate is this sign. This sign goes from a minus to a plus. So, and then the same thing down here. This sign stayed a minus. This is the one that went to a plus. So let's go ahead and multiply this out and we'll see what happens. So I'm still going to have the limit as x goes to 2. Let's see, first times first. That's 5x minus 5. Outers and inners, they're going to go away. And negative root 5 times positive root 5 is negative 5. So in the bottom, we still have our x minus 2. I'm not going to do anything. I'm not going to FOIL with this because I'm going to end up canceling, I think, an x minus 2. So let's go ahead and just write out what we have. Plus root 5. All right, there we go. So in the numerator, let's see, I'm seeing that I have the limit as x goes to 2. 5x minus 10. Does everybody see that? That becomes a 5x minus 10. And it's still over x minus 2 times 5x minus 5. Square root of 5x minus 5 plus the square root of 5. And that fraction bar goes all the way over. So let's see. 5 is going to come out of this numerator, 5x minus 10. That could be written the same as, let me see if I can do a different color here. That would be, if I took this 5 out, I'd have x minus 2 for that. And that x minus 2 is going to cancel with this x minus 2. So let's go ahead and do that. So x minus 2, I rewrote this in red, and x minus 2. Those will cancel out. So that leaves me with a 5 in the numerator and this stuff in the denominator. So I could be a little bit lazy by nature here and go to direct substitution because I only have a 5 in my numerator. In my denominator, if I substitute a 2 in place of x, I have 10 minus 5, which is 5. So that's root 5 plus root 5, which gives me 2 root 5. I guess I didn't need that much space, so let me shorten that up. Okay, so here's where a lot of times students get hung up. You need to rationalize the denominator, at least on these problems, especially when you check your answers in your book or in your solution manual. You're almost always going to see this rationalized. And that's what makes calculus kind of an algebra-intensive subject. Students who struggle with calculus usually will be struggling with algebra. So in the numerator, we have 5 times root 5. The denominator, root 5 times root 5, well, that's just 5. And 5 times 2, that gives us a 10. So I have a 10 here. And then 5/10, that reduces to a half. So we just end up with root 5 over 2. So notice, remember when I said sometimes when I see a radical up here, I notice almost always will see a radical down here as well. But this part is sometimes the hard part. This is done in Algebra 2, so you have to remember it for pre-calculus and calculus. So our final answer is radical 5 over 2. So I hope you're getting value out of these. If you are, please share it with a classmate and give it a thumbs up down below. I really appreciate it. And I'm going to try to focus mostly on calculus. Don't have a calculus class this year, so I got to maintain my skills for next year. So until the next time, this is Mr. Nolde signing out.